Hey everyone. So this is the assignment for Monday, acid-base neutralization quiz. So the idea behind an acid-base neutralization is the following. So let's say you have hydrochloric acid, strong acid, and sodium hydroxide, strong base. This is going to come together, do a double replacement reaction to make H2O and salt. So we know that this guy is going to be an acid, this guy is going to be a base, and when it comes together, it makes something that is really neither. So it's neutralizing each other. Okay, and if we wanted to go through and make this a little bit more accurate, what we're doing is having hydrogen ions in the chlorine and OH ions, hydroxide ions. And there's the sodium ion. And then when these come together, you're going to get H2O and sodium ions and chlorine ions. These guys are going to be, ions. They're going to be aqueous, dissolved. And if you remember from your net ionic equations, they go away. So really the only thing we're talking about here is the H plus, the OH minus going to water. That's the only thing we really care about. So if we want, we just need to know what the concentration of H plus is and the concentration of the hydroxide OH minus. These are the things that we really, really care about. Okay. And let me go through and give you an example of a problem that I'm going to be wanting you to do. I'm going to want you to do 10 of these problems, 10 correct answers. So, strong acid, strong base neutralization. I honestly don't care if you do the lists of givens and wanteds or the word problems. Word problems, all you have to do is kind of just figure out what we're after. If you are really serious about the AP exam and you want a bit of extra practice, do the word problems. If you are, not as serious, then do the lists of givens and wanteds. That's fine as well. So, or do 5 and 5. It's a good mix. So, let's go through and show you what I'm talking about. Okay, so this is going to be what you're given. You have a volume of calcium hydroxide. Calcium hydroxide is here, CaHOH2. That 2 is going to be important. And we're going to have a volume of a constant and concentration for perchloric acid. This is a strong acid. This is a strong base. So how are we going to go about, and they want to find the concentration of calcium hydroxide necessary to completely neutralize the perchloric acid. So let's go through and think about this for a second. All right. So we have CaOH2 plus HClO4. And remember, if we wanted to rewrite these guys as ions, we would be getting Ca 2 plus and 2 OH minus. Ha, told you that 2 is going to be important. Plus H plus and ClO4 minus. All right, and like I said before, these ions are going to cancel out on the other side, and this is the only thing that we are going to be doing is H2O. If we wanted to balance this out, we'd have to balance out, have 2 H pluses in this. This is going to be important. All right. So what we want to know is what is this concentration of O of calcium hydroxide? So what we need to first figure out is how much how many moles of H plus is in this 0.08 molar per caloric acid. That's going to be step one. Basically, take the thing that you know both, the volume and the concentration, and turn this to moles. Okay, that's going to be step one. We need to figure out the concentration here of this guy. All right, so we can go through and do that pretty easily. We know it's 0.08 moles per liter, and we know that this can be converted to liters by moving the decimal place over a couple times. 0.0572 liters. 1, 2, 3. Oh, there we go. Yes. Okay. So now we have that. So we can grab ourselves a calculator and figure this out. 0.08 times 0.00572. And this is going to be how many moles of H plus we have. All right. Now, here's the thing. For every 1 mole of calcium hydroxide, we're popping out 2 hydroxides, right? Which means 1 mole of this will neutralize 2 H pluses. 1 mole of calcium hydroxide, OH2, is going to neutralize 1 mole of H plus. So what we can do is just divide this by 2. Boop. So there we go. Now this is how many moles of calcium hydroxide we are going to be using to neutralize the perchloric acid. Then we need to figure out, we have moles, and now we have milliliters. We need to figure out the concentration, so we need moles over liters. Let's change that to liters. So that's going to be 0.15 liters. Take this and divide it by 0.15. Boop. And here is our concentration. So I'm going to move it over to the other screen so I can type as well. 0.00152. 5. That should be enough. All right. And let's see if I was right. Grade it. Waiting. Waiting. Hey, correct. So, there's that. Start over. I'm going to just be doing 5 and not 10 of these. So this is going to be basically how you go about doing it. You can, oh, come on. There we go. What you're going to want to do is set up the reaction. Okay. Oh, this one's a lot easier. So we have HCl plus NaOH, and this is going to go to H2O plus NaCl. And from this, you can balance it out 1 to 1 to 1 to 1. Everything's to 1. We don't have any shenanigans there. Okay. Now, you need to go through and figure out what are we wanting to find. We need to find the milliliters of 0.05 molar hydrochloric acid necessary to neutralize this. So what we need to do is use this to convert to moles. So that's going to be pretty easy. We have this moles per 0.714 moles over liters. Moles over liters. We have 0.180 liters. Just I can't converted milliliters to liters. Then we will convert 1 to 1, and this is going from OH to H plus. All right. And now we have moles of H plus. And we need to get to milliliters or liters, right? So what we need to do is put liters on top, moles on bottom. We can do that with this. So 0.05 moles per liter. So I just took the molarity, flipped it, and to get my units correct. Moles cancel, and we got it. So pull out my calculator. 0.714 moles times 0.18 liters, 1 to 1, and then divide by 0.5. We need this many liters, and they're wanting milliliters, so then we need to multiply this by 1,000. 2,570. Yeah. Yeah, that does make sense. 2,000, what was it? 570? Okay. Okay, so does this make sense? Does this large amount of acid make sense? Well, yeah. I mean, look at this. We have a very dilute 0.05 molar acid, very dilute molar acid, and a lot higher molarity of sodium hydroxide. So we have something that is very concentrated, and we're trying to neutralize it with something that's very dilute. So yeah, this does make sense. So those are the two ways that we can go about it. The things that you need to remember here are the following. Remember that you just need to match up the concentration of, not concentration, match up the number of moles of your acid and your base. Figure out the number of moles in your whatever the other thing is that you're looking for. So in this case, we're looking at the base. Figure out the number of moles here. Remember that you need an equal number of moles to neutralize it. This is basically stoichiometry. So we have done that. Then once you have done that, go to whatever unit is that they are asking for. So for molarity or volume, you can do that. It's still going to be the same thing that I mentioned before, where you take, whatever unit they're giving you. Like in this case, they're giving you molarity and volume. Then you go to moles, and then you do your stoich step, which is get you moles again, and then you go to whatever it is that they're asking you to go to. It's still those same 3 steps. Let's do this one again. All right. So given we have 160 milliliters of strontium hydroxide. Now, then this case is again has 2 OHs for it. Then, and we have 3.367 mils of 0.01 molarity hydrobromic acid. All of these are going to be strong acids and bases. And we want to know what is the molarity of, so we need moles and liters to neutralize this. All right, so again, we need to figure out how many moles of this do we actually have. So if we have 0.01 moles of hydrobromic acid per 1 liter, and we only have, convert this to liters real quick, 0.00337 liters. Liters are going to cancel. I have now converted this to moles. I have done get to moles step. Okay. So now let's do the stoich step. I know that I'm going to need, for every one of these, we're going to need 2 HBRs, 2 H pluses, to neutralize one of these. One of these is going to spit out 2 OHs. So that's that. So HBr down here. 1 to 2. Strontium OH2. Okay. So now we've crossed that out. We've done our stoich step. Now we need to get to moles over liters. We currently have moles of strontium hydroxide. So we need to put liters on bottom. I have the volume of strontium hydroxide right here. So it's going to be 0.160, because I converted to liters. And that gives us our full math, our equation there. All right, let's do this real quick. 0.01 times 0.00337 times 2 divided by 0.16, and that gives us 0.000421. 0.000421. All right, let's see if I'm right or I made a mistake. Grading it. Ooh. What did I do wrong here? Should be 1.5. What did I do wrong? Did I multiply by 2 instead of dividing by 2? I should have divided by 2. Yeah, it takes 2 hydrogens to get rid of 1. I put my 2 on the other side. Shoot. All right, so let's look at the calendar. And is there a way to do history? I have a history on here, don't I? Nope. Okay, let me just write this down so I can get this right. Oh, move it over here so I can actually see it. All right, so what I did was 0.01 times 0.00337. In this case, I need to divide by 2 and then divide by 0.16. All right, so let's try that again. 1. There we are. I think I even said it. I said it, hopefully I said it the right way, where we need 2 of these to neutralize 1 of these. I just wrote it down wrong. This is one reason why I like dimensional analysis, is because you can see your mistakes and quickly see what's wrong. Okay, so there you go. So this is going to be your first part. You just need to do 10 of these. I apparently need to do them a little bit more as well. The second thing is titrations. Now this looks a little complicated. I wish that we could have actually do a lab of this, but we just, things. When we come back in January, I have a plan to do some labs. So what I want you to do is fill this up, or, follow along. So first thing is select type of reaction, strong acid, strong base. We're only going to worry about strong acid, strong bases right now when we do calculations. And you're going to fill the beer up with acid. Select acids. First one I want you to do is the standard HCl NaOH. All right. And indicator. So whenever you're doing a pH reaction, you have these indicators. So this is a chemical that you'll put in here that will change color whenever the pH reaches a certain place. Bromothioyl blue will change yellow whenever it hits pH 7. pH 7, you may remember, is when things are neutral. So what we're going to do is neutralize this. So again, this is going to be just like those neutralization reactions, except we are doing something here. So we're going to be neutralizing this molarity and this volume of base. And it's going to be the exact same process as before. We need to figure out how much OH we're putting out here. And so if we do that, it's going to be 0.136 moles per liter. And then this is 0.025 liters. And this will get us our OH. All right, so let's do that math real quick. Times 0.025, and we have 0.0034 moles of OH. Now we don't know what the molarity is up here. We don't know what it is. So what we're going to do is start filling this up until we see a change here. We know that change is going to be pH 7. Then we can stop and do the calculation to figure out what this molarity actually is. All right, let's go through and do it. So what you can do is use this slider to kind of quickly drop this down. You don't want to just do it willy-nilly. Let's say you just want to do it a little bit at a time, like 2 mils, 2.5 mils. Okay, didn't change. A little bit more. Nothing. A little bit more. Nothing. Okay, maybe a little bit more. Nothing. A little bit more. Nothing. A little bit more. A little bit more. More. I'm not seeing any change yet. Nothing. Oh boy. Oh, there we go. I may have gone too far, but let's find out. So we put 20 mils in here, right? So if we kind of continue this along, this should be 1-to-1 dilution, or 1-to-1 stoichiometry, because of its HCl plus NaOH. Hopefully you guys can see this is going to be a 1-to-1 stoichiometry here. So then, 1-to-1. Then we need to have 20 milliliters, or in this case, 0.02 liters. We'll have that. All right, so divided by 0.02 liters. And so this is going to be the concentration, 0.17. Let's see if I went over. Incorrect. It's going to be a little bit less, like 0.16. Shoot. Okay. So this button here is going to keep everything the same and just kind of reset everything. Let's multiply this by 0.02. Set it back there. All right. So again, let's kind of go through. We're up to about, we did 18. Okay. Let's do 19. Oh, Okay, 19 mils. 19 mils did it. All right, so we can divide by 0.019. So it's 0.178. There we go. Hooray. So this is what I want you guys to do. I just want you to do it once, just with this. So HCl NaOH. Take a screenshot of this and see the word correct here, and then submit that as well. So 2 things, 10 questions from the acid-base neutralization and 1 correct titration experiment. So that's what's going on today. All right. You can also do kind of a drop-wise thing. So if you hit, 18.5 and you're like, it flashed yellow, just do drop-wise until you get the exact number there. All right. Have a good one, guys. I'll see you guys later.